Okay, so picking up right where we left off in this video, we should finally be able to get to the code that changes the color of the token. My apologies if the last couple videos have seemed kind of meandering and kind of nebulous. It's because there's a whole lot that you have to put into place, basically a series of variables and tags, and based on the combination of the values of those variables and tags, determine whether or not the token is changed color. And as I mentioned, this is really an issue of logic, not of coding. The code, we only have like a couple dozen lines of code, if even that, and we're only going to add a few more lines in this video. But again, it's the logic. It's really a logic puzzle, not a coding puzzle. So what we're going to do is the first thing, we're going to modify the script. We're going to add to the script for the probe. So right now, all the probe does is when it's instantiated, it starts traveling in an upwards direction to the upper left. What we need to do is we need to start checking for collisions. So outside of start, outside of update, on trigger, enter 2D. In short, this is saying if there is a collision with a collider, a 2D collider that is set as a trigger, then there's certain things that we want to happen. Now, collision, for want of a better term, is the handle. It's the reference to the object that is being collided with, as opposed to the object this script is attached to. So I personally don't like the fact that it defaults to collision. That makes it sound like that's more of a functional word. So some people will use other to reinforce and remind them that when you use other in here, you're specifically referencing the other object, the object that is being collided with, rather than the object that the script is attached to. So what we're going to do, so if the probe, so it collides with an object, if the tag of that object, so other, if the tag equals E, and that is we're using that for the empty blocks, then we destroy the game object that the script is attached to, which is the probe. Why? Because that's the rule of Othello, that you place a token, and once you hit a blank, you stop. If you hit a matching one, you also stop. So in this case, we want to destroy the token. Not the token, excuse me. We want to destroy the probe. So if the tag of the object that is being collided with is E, which is an empty cell, an empty block, then destroy the probe. If it is B, actually, rather than doing the value B or W, what we need to do is we need to look at the current turn. So as we mentioned, when you click on a block, this is what's really indicating the turn. So you place a token of the current color and then the turn changes. So we actually don't want B. What we want to do is we want to look at what the current turn is. So if the tag of the other object matches the current turn, then that should also lead to the destruction of the probe. So if other.tag is equal to gameflow dot current turn, then we also destroy the object. And then the last thing, actually there's two more. If it goes beyond the boundary of the board, that would also be the equivalence of reaching an empty square and therefore would be destroyed. But we don't have to code for that, because what I'll do is when I create the boundary, I'll also use the E tag. And so this will simply say not equals to. So that's how you do a not equals. You do an exclamation point. So if the tag of the object that's being collided with is not equal to the current return, then you want that tag of the other to be changed to flag it as a potential change and we don't destroy the object. So we don't destroy the object, and then other dot tag is equal to the tag of the current game object. Or should I say the game object this script is attached to. Okay, so those are the three basic conditions that can happen. The probe collides with an empty square and therefore destroyed, and the turn should end. At least for that one probe, there's going to be one sent out in each direction. It could collide with a matching one, which should also end the turn, or it's going to collide with an opposing color, and that other one should be flagged as potential to be changed. So we're getting close. Now what we need to do is we need to also state that this has reached its final status. So that's why we created that other variable. So in game flow, we created that UL status, and we're going to say it's going to be either yes, no, or reverse. So if this reaches an empty, then anything that's been flagged should be reversed. We just haven't checked for this yet. If it reaches a matching one, then gameflow.ul change should be yes. In other words, yes, anything that's been flagged as to be changed should be changed. And this, if you reach one that does not match, that doesn't end. So this should not be changed. It should keep going because say you placed a black, the probe collides with a white. Okay, well, it doesn't stop. It keeps going. So this should not, colliding with the opposing color should not end the turn. All right, so that's the bulk of what's going to take to control the probe. Let's just quickly go back to the scene, and what we're going to do is we're going to add the border and flag that as E. So game object, create empty, and we're going to add physics 2D, and we're going to do box collider 2D, and it's going to be a trigger, and now we're just going to make this a border. How far over is it? We'll just move it a little bit more. And we'll flag this, as I said, with the tag E. So what happens is that when the probe is traveling, if it hits an empty box, it should stop, okay? But say this isn't empty, so it hits this one. Depending on what this is, it might keep going. So we need to know that it's going to stop when it gets to the border there. So we'll just copy that. I'm not bothering changing the name of this right now. I'm really just kind of focusing on wrapping this up because this has actually taken way, way longer than I thought it would, which is really my own fault for not planning out ahead better and underestimating how slippery that logic can be. Because like I said, this really isn't an issue of coding. Certainly you do have to code. The problem is one of logic. It's easy to store a yes or no. It's much harder to store a maybe because you then have to reset those maybes. Okay. So, and since I added the tag to the first one, they should all have the tag. So if the probe goes beyond the border of the board, it will also be terminated. That is the bulk of the controls for the probe. Now what we need to do is now we need to have the tokens respond. Like for instance, we need the token to actually reverse the value if this happens, or to change their color if this happens. So let's go ahead and do that. So now what we're going to do is we right click, choose create, C# script, and we'll call this token con. So the script to control the tokens. So we'll click on one token, open, put on the script, click on the other token, open, put on the script. Now we open that. So the first thing that we need to do is, as we indicated, we are going to be changing the tag. Right now, the tag was the only way to determine whether or not, at least from a data point of view, visually you could determine if a token is black or white by the color, but from a data point of view, the only way to determine was based on the tag. So since we're going to change the tag, that means we need a secondary way of determining whether or not, or what color a token is. So yeah, I really probably should have put this in the previous video, but that's life. I really kind of underestimated how much of a challenge this was going to be, and I tried to wing it, and well, you've seen the results. So public, and this should not be static. We want every single object that the script is attached to have its own unique variable, so do not make it static. So public string, and it's just going to be CUR color. The reason why I'm not using current color spelled out in its entirety is because I'm thinking that actually might be a reserved phrase. So always be mindful of that you're not using something that already has a predefined meaning to the system. And that's good advice, not just for Unity, but for like databases or any kind of technical programming or design. There's these reserved words and phrases that have like a functional meaning. So the current color. So what we do is at the start, what we get, that is when the object gets instantiated, which happens when you click on the board, we're going to set current color is going to be equal to game object, so the object the script is attached to, dot tag. And this is another reason why you want to keep that consistent naming, because I made a point of saying that the current turn uses B and W, and that the tag uses B and W. So by keeping that consistent value, we can now transfer that value to this variable. So every object will now keep track of what its tag is originally. And this only happens once. This happens when it first instantiates. So now what we want to do is we want to check to see if the color needs to be changed. So we're going to refine this over time. But again, like I said, you kind of have to put the basics into place. So when would we change the color? We would change the color if A, its tag has been changed from B or W to in this case, UL. And then what we want to do is we want to then determine if the UL status, the UL change is yes, no, or reverse. So keeping that all in mind, so first we're going to just do a top level check to see if UL is even the probe that collided with this object. So if game object dot tag equals UL. So if the object the script is attached to, its tag is UL, and it should only be UL if a collision occurred, we then want to see, well, do we do anything with this? So we then check, so basically nested if statements. We then want to see what the status of UL is. So if game flow, again, if you're referring to a static variable, you have to declare where it's stored, and it's stored in game flow, or where it's declared. Game flow dot current turn. Oops, sorry, not current turn. My apologies, getting ahead of myself. If game flow dot UL change equals, remember, if you're checking, go to do the double equal sign, Y. Okay. So first we're checking to see if the tag is equal to UL. If it is, we then check to see what the corresponding status is for UL. Does it say yes, we should change? No, we should not change, or R equals reverse. So if this is Y, then what we need to do is we need to flip the color. So that means we then need to see what the original color was. So a couple ways you can do this. You can keep nesting these ifs, or what you can do is you can check everything here. 6 one way, 1/2 dozen the other. Now, when you have multiple values that you're checking, gotta put the whole thing into parentheses. So the entirety of what you're checking is in parentheses, and then each and every variable within is in its own parentheses. And yes, it's a double ampersand. So if UL is set to change and current color equals B, then we change it to white. What doesn't it? Oh, I forgot the second equal sign. I only said that 5 seconds ago and I still violated it. Let's try that again with an actual statement. Get component, sprite renderer. We looked at that way back in, I think, the first video where we went into the sprite renderer and changed the default color. So if it's black, we need it to change to white. So that's 1, 1, 1. And actually, we're going to then want to set the tag to correspond to that. So game object, again, game object is the object the script is attached to, and this script is attached to the token. And so we said it's changing from black to white. And now, partially because I am lazy and partially to reinforce that this is just rinse and repeat, we just copy the whole thing and then we just flip it. It's checking if it's currently white, then therefore it should be changed to black, both in color and in identifier. Phew, we're getting really close now. And this is what I was talking about. This isn't a whole lot of code, but you're checking multiple values. You're checking multiple conditions and then making choices based on those. And in this current version, we're also going to have to repeat this for each and every probe, and there's 8 probes. So part of designing a game, an application, you make something that works, and then you go back and you trim the code. It's an iterative process, and so you make it run better, make it simplified. So we might actually make this be kind of wordy at first, and then find a way to make it simpler. So the first check was if the tag is UL and the change is yes, then we need to make the change. What if the change is no? So we copy this whole thing. And if you want, you can put remark statements in here, like you can do this, and then put a statement, which basically would be self-documenting. So you would say the following are for yes, and then put a break here, and do another remark statement that says the bottom is for no, that kind of thing. So if UL change is R, so reversed, and the current is B, well, since it's reversing, we never change the color, so that can go bye-bye. And we would simply revert this back to what it was. So as you can see, this is flipping from one to the other. This is reverting back. So all we did was change the tag when the collision with the probe occurred. Now we're reversing that. So same thing. No need for color. All right. So now the last one that we really have to check, and it's more of a housekeeping kind of thing, is no. Because if the variable no is basically the default value before anything has been changed. So no for UL change, which means we really have to acknowledge when the turn ends, and then when the turn ends, the UL change would be set to no. Okay, sorry for that brief splice there. I needed a bit of a break. So the way we've set this up at the moment won't actually work until we undo something that we did in the first video. And that is for the click conscript, what we did was as soon as you click on a square placing a token, we immediately change the turn. Here's the problem. As that probe is traveling, it's looking to see what the current turn is. Well, we've already changed the current turn, so it's going to be looking at the wrong turn. So there's a few things you can do that are counterintuitive, like you instead of looking for the current turn, you could look for the opposite turn or things like that, or you could just create a delay before the turn is changed. We're going to go for the latter. Part of the reason for it is because the original person who requested this series said they wanted to learn about C#. So by showing you how to create a delay, it's additional code that we hadn't looked at before. So when we place the token, we now want a delay to give the probes a chance to do their job. So what we're going to do is we're going to just put a couple forward slashes. Basically, we're remarking that out. We could just delete it, but I'm going to need at least one of them shortly. What we do is we're going to add a new routine. So outside of start, update, and mouse down, we're going to do IE numerator. We name it, and we'll call it wait to change, and parentheses. And this is one of my pet peeves. As much as I like Microsoft Visual Studio, this is a pet peeve because it's underlined, so it's making you think something's wrong. There is nothing wrong. We just haven't finished yet. So what we want to do is we're going to want two different ones. We're going to want wait to change W, and then we're going to do wait to change B, but we'll just copy this one. So what we're going to do is yield return new wait 4 seconds, and we'll give it, say, 6 seconds to complete. And then we do the change. So we said wait to change W, so we'll use this one then. Okay, so I usually like to explain what everything does, but just know that you have to type this, and what you really care about is this. So yes, you have to type yield return new, but ultimately what you're doing is you're going to type out wait for seconds and how long you're going to wait. So you're saying to delay and how long to delay. This can be a variable. This can be a decimal. You just have to put the letter F after it. So it could be like 5.5, but you'd have to put 5.5F. And what we're going to do is instead of immediately changing current turn to W, we will instead start coroutine, parenthesis, the name of the return of the coroutine, including parentheses. So basically, this whole thing in parentheses. And now, again, rinse and repeat. Copy, paste. We'll call this wait to change B, and this will be B. And then we'll grab this, and we'll put it up here. So code's getting a little bit more cumbersome than I like, but ultimately we had to make the change. We could no longer change the turn immediately. We now have to create a delay. There's other ways to do it, like you could check to see if every probe has been destroyed and then change the turn. Again, I think this is the lesser of two evils. So now we create a delay of 6 seconds before changing the turn, and 6 seconds should be plenty. And another piece of housekeeping that we need to do is when we place the token, what happens is that, let's go to the token script. As soon as you place the token, it has a collider. Well, the probe that is being instantiated can collide with the token that you just placed, and you don't want it to do that. So what we need to do is we need to temporarily disable the collider and then enable it after, like, say, 2 seconds. So get component, and it is circle collider 2D. So again, make sure you're doing this on the script for the token, and enabled equals false. That should look familiar. We did the same thing to the squares, so that when you click on the square, we disable the collider. And what we're going to do is similar to what we just did to this script here. We're going to do a coroutine. So what we're going to do, so back to token, outside of update, outside of start, we're going to IE numerator and activate, we'll call this activate delay. Again, it puts the red squiggly underline even though nothing is wrong. Yield, whoops, let's try that again with an actual command. Yield return new. And again, don't worry too much about the meaning of yield return new. Just know that you need to enter it in order to actually create the delay. And this one doesn't need to be doing as long. We'll just do 2 seconds. And then we will reverse what we did up there. Get component, circle collider 2D, and this time enabled is equal to true rather than false. You've enabled that component. And now we need to actually refer to it. So start coroutine, and again, parentheses, plus the entire name, including its parentheses. So you place the token, its collider is disabled for 2 seconds. So it's disabled, wait 2 seconds, and then enable it. One more piece of maintenance we need to have when the turn ends. So we did that with click con. When the turn ends, we also need to reset the default value of the status for the probe, because we said that for the probe, this determines whether or not tokens that have been flagged should actually change. So UL change is going to be reset when the turn changes. So let's go to, so we're in the click con script, and this is gameflow.ul change is equal to no. So no is more of kind of the default pending status, because the change will occur when a value is set to R or set to Y. So for reverse or yes, actually proceed with the change. So that means you need that default value where neither one of those have been determined yet. And we need to do that for both turns. And having done that, I believe we now have enough code in place to test. So let's go to the scene. We'll run. We'll place, say, a white one. You have to wait for the 6 seconds. So again, like I said, you're going to want to come up with a better solution than that. We'll place a black one. We're just going to place a white one off to the side. And then when we place a black one, this one should get changed, but not until the probe reaches this one. Bingo. So there you go. That I'm not saying it's going to work for all combinations. I haven't gone through the code with a fine-tooth comb, but now you saw that clearly this one did not change until a matching one for the color that was placed was confirmed. And then when this was reached, the probe did stop. So like I said, we didn't actually add that much code. We added a few delays, like the IE enumerator, so that fluffed up the code a little bit more than I was initially thinking. But the actual checking, couple dozen if statements. And again, it's just kind of juggling these values and then making sure they're getting reset. So again, I'm not saying that this is going to work for all conditions, but I think this is a good place to stop because honestly, I've been working on this for hours. And again, it was my own fault because I underestimated the complexity of what was going to take to do this, but I believe I have fulfilled the request. Someone wanted to see the basics of Othello. And I believe you now have the what you need to continue. If you want, I'll see if maybe one more video is necessary because I did mention doing timers, doing scores. Someone said that when you point at a box, how about having the box highlight, things like that. So we'll see what your feedback is. So if you want to see more, do a like and a comment. And that's about it. So again, my apologies that this has been kind of nebulous, kind of meandering, but again, the core problem is that you are having objects flagged as potential to be changed, and that's usually not the way you do things. It's kind of a yay or nay. If an attack landed, damage is done, a variable is modified, reduced, HP is reduced, whatever. But in this, you have to specifically have multiple conditional values, and that only if they all line up do you then make the change or you then reverse. So it is kind of an interesting, challenging, logical puzzle as opposed to coding, because the coding for the most part, like I said, is just if-then statements. Okay, so I'm going to end it here, and again, I hope that this has been useful. Not seeing a lot of views on my videos, but I usually don't get many views on my videos anyways. It's usually not until like 6 or 8 months later that someone says, "Why'd you stop?" So I feel that if I do stop here, at least you've gotten the core coding and logic in place, and then it's just a matter of tweaking to make sure all possible outcomes occur, but it should be pretty solid. Okay, thank you all for watching, and I hope this was helpful.